Like,
All right, we are doing RT 111, group number 2. We're going to go over chapter, is it 30 and 31? Correct? Yeah.
Mhm.
Okay. All right, so I'm just going to kind of run through, and if anybody has questions or wants to put their 2 cents in, please feel free so you don't just have to listen to me. So chapter 30 was pretty much the pre-processing, post-processing and rescaling. Um, and from what I understand, like pre-processing is like like before you take the picture, like all the raw stuff. And then the post is like what you can do after you take the image, right?
call it like the refinement,
Yeah.
the adjustments made.
And then the rescaling is I don't know how to exactly explain rescaling, but the definition is final pixel value for are arranged to the image that will initially displayed by equipment. That will be initially displayed by equipment, right?
Mhm.
Yeah. Okay. And then for pre-processing, we have the DR systems and then also CR. And then there's flat field uniformity corrections, which are corrections made for the purpose of evening out overall signal or brightness across the entire area of the imaging field. And then there's the uniformity test, which pixel values after a low exposure is made on the plate and are compared to each other and must be aligned within a small percentage range. I guess the variable skincter, how do I say that word? Skincter.
What?
In scintillator? Oh,
Scintillator.
scintillator?
There we
A
go. I'm like,
scintillator. Like, are you talking about sphincter?
okay, that
Thinking
word
about
a nap
nap
today.
today.
Jeez Louise.
That's funny.
Um,
Oh.
okay, well, apparently I can't pronounce anything. The thickness, variable thickness,
Mhm.
thing about that in there, which is from just the phosphor layer varying from different manufacturers, pretty much.
Mhm.
And then we got light guide variation and CR, which I haven't really used CR, so it's kind of hard to like visualize some of the CR in my head just because I haven't
Mhm.
seen a ton of it, but just grateful that we don't have to do films.
Yeah.
That would make our life way harder. Um, and then another part of the pre-processing is the noise reduction for Dextal dropout. Um, and I guess Dextal dropout kind of confuses me.
I was gonna say, I'm a little confused on the kernels and like how exactly they work. Is the kernel actually like it's kernel isn't the dead space, right? It's more of the actual like Dexel that they're trying to fill with the kernels. I
Mhm.
have no idea.
That's what I understood also. Like, so for my notes, it says like it average out the pixels that is not working basically. So like let's say you have one pixel that's not working, that kernel pretty much kind of just
Build
assumes the surrounding of it is gray. This is gonna be gray too. Is from what I understood. I could be wrong though.
so it fills in like it
The
detects
dead space?
that it's
Hmm.
a different
Yeah,
level and fills it into whatever is surrounding it, correct?
correct. Yeah. That's
And
from what I
levels
understood.
it out
Yeah.
to that
Well,
that contrast kind of
would you say?
and like kind of like levels it out to the contrast that's surrounding it.
Yeah, I think like if let's say just a random number as far as histograms go, like all of the surrounding pixels around it is 6, it would just assume that the one in the middle is also 6.
Okay.
That makes sense?
Yeah.
And what sense is it? Is it something that's built into the plate on the top, or does it just go to that area where the pixel had or the Dexel dropped?
Like what sense is the fact that it's not working or like how much,
Yeah, like
no? That's the part that I like I'm assuming it just like it's not working. It didn't receive any photons. So um it'll just assume from that point on. But I'm not sure for sure like
I
what
have it in my notes, it
where the current
averages out the pixel around the dropout, then fills the Dextral dropout with an average value. So
Mhm.
it's, I guess that assumes just
is
something.
just not working. Yeah. Like it
Yeah.
didn't receive anything, so it's
Just
just
Somehow
gonna
assuming it's
do
not
what's
working.
around it or like kind of
Yeah.
filter it
Yeah.
to what's right next to it.
And then like the whole row or column can fail. So,
Yeah, and then that means that the plate has to be replaced, like if it
Mhm.
starts doing that.
Yeah.
Okay. And then the third part
one
of,
more question on that though.
yeah,
Sorry.
it's okay.
That picture that we have in the lecture where it's like the original image, the kernel, and then it goes down to like an average and then a processed image. Like, does anybody understand the graphics of that?
I'm trying to
It's
find
in the
the
slide, and I believe
In the
it's
slides.
oh yeah, on page 480 as well.
Figure 3-2, 30-2,
30-2, yeah.
page 480.
Yeah.
Well, it kind of looks like it's taking up the dead space from the original image and goes to the processing image, which is basically what it does, right?
So it's just
Yeah.
kind of grabbing it, averaging it out, bringing it down to the processed image with the Dexel filled in.
that's what it looks
Defined as a submatrix that is passed over the larger matrix. I don't know if that helps.
Yeah. Yeah,
so
maybe
once it
that could be
alters
something we can ask him about too, but I think
Yeah.
it,
Well, I think that actually the like summary on the side kind of
Mm-hmm.
gives me a better idea.
yeah, simplifies it.
Yeah.
Yeah. Okay. So if we're all good with that, then we'll go on to the other part of pre-processing, which is image analysis, which I feel like is pretty self-explanatory. I mean, it's either noise or two types of noise, which would be it being too dark or too light, pretty much,
Mm-hmm.
right?
Mhm.
Um, and then I just have a notes on um or they're just different ways of the raw, dark, and light. And then it goes on to constructing the histogram, which we all probably remember what histograms are.
Yeah.
Um, a graph plotting pixel count for each brightness level, pixel value. Um, and then different proportions of the body produce a histogram shape with peaks and valleys. And histogram analysis, identifying landmarks within the numerical data so that only values of interest are included with the image when the image is rescaled and manipulated. So, and then I think it goes on more to talk about histograms, which is most common type of histogram, obtained for body parts that do not cover the entire area of the image. Let's see, what else? Computer must identify the tail portion and eliminate it from histogram analysis preferred, which I vaguely remember him talking about the tail whenever we
When we were in
our
lab.
lab that one day,
Mm-hmm.
right? Refresh
But
my
that made
memory of
more
what it.
sense, I think, after that.
What was that?
That I think it made more sense after we had that lab, so we could actually like see it on the portable.
Yeah. But
Um,
refresh my memory of what the tail is.
so the tail is like the raw exposure at the end of the histogram. So like where it kind of like cuts off, I guess.
Okay.
It's the black.
Does that
The
like the black
The blacks.
edge
The black.
yeah.
edging
Okay.
around the
Oh, okay.
actual
That-
image?
Yeah. I knew it was something simple, but I just needed a refreshment. And then process of excluding undesirable portions of the histogram from the desired. That just pretty much explains the tail, I feel like. What else here? And then it goes on to the types of histogram analysis, which is, wait, did I just do that?
I think you just
No,
talked
we're
about
talking about
the
histogram.
histogram
Okay, but then there's 3 different types, correct, of histogram.
analysis.
And I have one is if over collimation on the extremity results in a complete lack of background density. And then type 2 is assumes that there will be no tail in the histogram or background density spike. And then the third type is designed for a large bolus of positive contrast age, which like barium to be included in the projection. And to compensate for presence of lead shield or prosthesis. Apparently, I cannot talk today. So, I think those are the 3 types. Anybody have anything else to say about any of those?
Mm-mm.
No?
I think we went over that one pretty good on the
Mhm.
labs.
In lab, yeah. And then chapter 31 here, which is the digital processing, treating fine detail as separate component of the image without changing the overall contrast or brightness of the image as a whole. Examples, the detail enhancement or detail removal, sharpening or blurring. Can be executed in frequency or spatial domain. And then this has the part talking about applying the kernels to the domain. And the kernel kind of being a filter passed over the original image to make it mathematically functional. And then there's the unsharp mask, which is edge enhancement performed in the spatial domain. And then this is a 3-step process. Does anybody want to talk about the process?
Are we talking about like the ones in the spatial domain still?
Yeah, the unsharp mask, like when you do the edge enhancement. Edge enhancement has the 3-step process. Do you have that one?
Yeah, but I have edge enhancement. I can't talk either. Enhancement under frequency domain. Like, are they both on there? Like edge enhancement?
Edge enhancement performed in spatial domain. Okay, so maybe it's 2 different things.
I believe so.
Yeah.
Because there's three domains. And then for edge enhancement, I got that one under frequency domain. But then the 3 steps, which is the point, area, and global, I have that under spatial. Does that make sense?
My handwriting is pretty sloppy and I handwrote these ones. So
Are you?
I have a 3-step process, which is the first one is structures smaller than kernel matrix are removed, creates a blurry image. 2, positive inverted image is created. All gray values are mathematically inverted. And then 3, the positive inverted mask is subtracted from the original image, leaving only fine detail. No?
Yes. I'm
So
trying to
that
see.
has nothing to do with unsharp mask. That's something separate.
I'm not
Yeah.
seeing it either.
Oh, I see it. I see it. I see what you're saying. But I also have it under frequency domain still. The
Oh,
unsharp mask edge enhancement performed in the spatial domain
so
through
maybe like the kind of the same thing. Then it's just two different.
like they're both under like enhancement. The edge enhancement is under both frequency and spatial domain, I
Oh,
guess.
okay.
Is
Makes
the way
sense.
it looks like.
Yeah.
Okay. We
We
have to
have to
move.
move because they're closing, I guess.
Oh,
I don't know.
they're kicking you guys out. You're getting kicked out of the library.
We're getting kicked out.
Library.
So we'll
Maybe
just
just this room.
move outside. You guys can keep talking while we're moving so we don't miss.
We might run out of time though, I think.
Yeah. All right, guys. We didn't know.
Okay. And then it pretty much says that the radiologist can apply and remove edge enhancement when needed. And I think he was saying in his lecture, like, try not to do the edge enhancement because then it makes it so the radiologist can't do it.
You can't access the gray levels.
Yeah, I think
Yeah.
the more you mess with it, the less the radiologist is able to do.
Yeah.
Good.
Unless he tells you like to go back and resend it, I guess.
Yeah.
You
And
do.
I'll just sit right here.
Yeah.
Yeah.
Okay.
So we don't lose internet.
All right.
Okay.
Okay.
Open.
It happens.
What time is it? Like, damn, they close early.
I didn't know they put
It's
so
Friday.
I know.
Friday for
It's
them.
early everywhere.
And then there's the processing and the frequency domain, which is based upon size of the structure, object, and the image, which correlates to the wavelength of frequency of their function. And then in my head, I'm trying not to get these actually, I guess it's the same with the physics where it's smaller details is higher frequency and larger waves is lower frequency.
That's funny because I was thinking about that too.
Yeah, I was like, I don't want to confuse them or mix them up between
Yeah.
classes.
Wonder if like they're related somehow.
Yeah. So that makes it easier, I guess. And then the image scanned in rows, pixel rows, higher the frequency, fewer pixels. And then pixels per detail, higher sharpness of detail.
Hmm.
So I guess where like that gets confused in my head too.
Yeah.
And then whatever this guy's name is, the transformation. Fourier.
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 Fourier. Okay. So this is the mathematical process in the frequency domain that breaks the complex waves that form an image into wave components. And then there's the inverse transformation. Let's see. What else? Does anybody have any questions about any of that stuff?
Mm,
No?
I'm looking at the hold on.
Yeah, me too.
So I was like, I think
I guess my question is more so about like the noise reduction. We haven't brought it up yet, but it's like further down chapter 31. That's
Yeah.
the part that like just confuses me the most.
is that the where
Like it says
like a
noise
periodic, random, and noise, that sort of thing? Okay. So noise, any form of non-usual input.
Where's that at?
It's further down chapter 31.
It's
Under yeah.
under preparation for display, and there's like there's the noise, periodic, random, and then noise again. Or noise frequency.
See the
Smaller artifacts that are roughly consistent size occur regular patterns across the area of the image. And then random. I guess periodic is kind of like would be like fuzzy noise, I guess is kind of how I think of it in my
Mhm.
head. Like, And then the random, I think of just like dust or something on the, I don't know if that's right or not, but I guess just in my head because it's like erratic, chaotic pattern across the image. Just kind of
Mm.
think of like something being on the um plate, you know?
Yeah.
And then the noise frequency layer removed. Some anatomy will be removed along with noise. And then I guess I think is the other one of like kind of something getting burnt out, you know, if like you have your KV too high
Okay.
or
That
like
one would be random.
which
What's
one?
that?
Is that one random? Like the one that's like you're gonna burn out your image with too
I
high of
would
a
The
I would
chaotic in nature
Yeah,
yeah, I would
that's
think that one
of
would I thought
quantum
that one
model.
was more like something like maybe if you don't use a good technique and then it's like kind of blurry maybe.
is
The,
random.
the
Yeah.
static in TV is like if the patient moves, right? Like
Oh,
motion.
maybe.
Oh
Yeah,
yeah.
that would make sense too if they
And
move.
then the quantum model, I think you're right about it's like burning like over using a high technique or a low technique.
Yeah. So it's either like blurring like too white or like too black.
Yeah, it'd be like if it's too black, I think you overexpose them
Yeah. You burnt
because
through
I've
'em.
done it before.
You just radiated the crap out of them.
So
Angel.
it can be too dark also, not just too light.
Yeah, I've done
Yeah,
Okay.
that. I probably shouldn't have
usually
done
like
I think we've all done it. I mean,
Yeah.
that's part of
yeah,
us learning, you know, and or like I've done it too if I had like the tube too close, you know, when you're like
There's
doing
not
an
enough
extremity and you have the tube and you're like, oh, I didn't even realize how close I had it to the patient. I feel like it burns through. But it's
yeah.
like
I did it
portable.
with like a chest decubitus.
yeah,
I wasn't able to like move the bed further or the tube further, and I just
oh,
forgot to lower the technique.
close, yeah.
And
Which
yeah,
I mean, how could
dark.
Don't think about that sort of thing. I feel like you're just trying to get it done and get it fast.
yeah.
I think we were already going through this, but I have a question about in the slides for 7.1 to 3. There's like the frequency lowest and highest, and I'm really confused on how there's 2 cycles and 5 pixel pairs in the low frequency and 5 cycles and 1 pixel pair in the high frequency. I think it's on the
I know what you're talking about, yeah.
1, 2, 3.
7-3.
Yeah. So the low frequency is
Oh, I see.
Like on slide 13, but wouldn't it be 1 cycle because there's not 2 cycles, right? Or like,
I don't know. I just kind of have it in my head as like
I'm kind of confused. Like,
and the higher frequency is 5 cycles. I don't know. That's just how I
wow,
like remember it
wow.
in my head. But because I don't quite understand what that means, even like the cycles per pixel pair. Like, I don't know what that.
Yeah.
The first one, A, it seems like it says it's 2 cycles, but it just seems like 1 full cycle.
Yeah.
It doesn't
I get
complete the
B.
second
B makes
phase.
more
It's a
sense.
typo. Maybe it's a typo.
That's what I'm wondering though, seriously, because I was like, how? So I don't know. I just figured I'd ask you guys and see if you knew.
Yeah.
I
Are you
think it's
saying that the
typo
the
too.
figure says A figure A says something else, and I mean it says 2. I mean, sorry, it says 1, and then the bullet point says 2. Is
Yeah.
that what you're saying?
Yeah.
Yeah.
That's true.
So it's probably just a typo then.
Well,
Yeah.
hopefully
Okay.
Professor Steele can explain that one
Yeah.
because
He'll let us know. We have 6 minutes left, so I just was gonna kind of like breeze through the last little bit here.
Mhm.
Which is formatting for display. And then display systems are the weakest link in the radiology exam. I think I can read from my handwriting. Resolution format must match high resolution on the low or on low resolution monitor. Operator adjustments, which is like the window brightness, contrast, masking, reorientation, edge enhancement, which also so grateful that we have digital because I would imagine it'd be way more complicated to do that with film.
Mhm.
And then special post-processing, which is dual energy subtraction, production of bone only or soft tissue only images by tissue types with the change in X-ray attenuation. I think that's like pretty much it.
Hmm.
Maybe
Do you guys do a lot of that at your clinical sites?
do it.
I think he mentioned
The
that it's like just now coming up,
the
like
the
between sites, like it's something newer because I like the equipment that we use at Lompoc, it's pretty new and I've never seen that.
Like
team.
the dual energy subtraction.
Mm-hmm.
Mhm.
Yeah. I haven't seen it.
Yeah, I don't think I've seen it either.
You guys clean up your images a lot when you're before you send them?
Not really. I just
No?
like
Really, the
like the
text,
orientation or
check it
some-
out.
yeah, like make it.
I annotate it more than anything. Like it's a portable. This was done in supine,
Yeah,
Mhm.
cross table.
we do that part too, but not the actual like
Yeah.
sending out
Yeah.
to the radiologist.
Why you're manipulating everything over there, Angel, or what?
No, I'm
Who?
just saying I only bring it up because I'm not sure how you guys are, but obviously we do annotate it
Yeah.
at the console where the computer's at.
Yeah.
But then when we send it to the computer that's in the department, we could like make it look nicer, I guess.
Yeah.
But now we're getting a new system where we can't do that, so we have to really collimate really well now. It
Oh,
has to be perfect now. So they're taking away our ability to fix everything, or what is it called again? To adjust like to
it?
take out the valve
Whenever
glare
you're
and all
like
that stuff.
masking it, or it's like
Yeah, exactly.
Cropping?
masking,
Yeah,
you can like
cropping, and then
Yeah.
yeah. So we have to be on point now, starting next week.
it
Wow.
is
So
definitely
your collimation be perfect.
and that's hard. I
Yeah.
feel like especially as like us first years.
Yeah, because
It's
obviously, like a
hard.
lot,
I leave that
obviously
open.
we over collimate because we want to get everything.
Yeah.
Well, not too much, but you know what I mean.
I feel
Now it
like
has
I
to be by the book.
definitely am scared to like
Yeah,
collimate too tightly with certain
Right.
things.
and especially because we do a lot of bilateral stuff over there.
No,
That's
that's
So when
hard.
we crop,
We
yeah,
have
we
a
like
lot
to
of
crop.
empty
We
space.
like to crop, but now we have to do it at the console, which is going to take up more time because we can't do it. We can't send it to the computer, and then we could do it there, and then the other tech could use it. Now we have to waste more time there, and then it's going to suck. That's what I'm trying to say.
You got 6
Yeah.
It's gonna be the next student's problem, not yours.
That's true too. I only have to deal with it for a few weeks, I guess.
Yeah.
Yeah.
Exactly. All right. Well, does anybody have anything else they want to share or discuss?
Let's study more for the test.
Gotta study.
Nothing that I could
helpful.
that I had notes on that we didn't already cover. So
Yeah. I'm gonna stop recording.